Let's take this opportunity to explore some of the issues surrounding the recovery of complex mixed metals from residual wastes, such as electronic scrap, by utilizing the hydrometallurgy method. The Recovery 2.0 system is an innovative approach to manage the treatment of residual waste materials, in a sustainable method by treating waste as a resource, while assisting with the world's demand for clean water and clean energy by using thermal reduction. Within the Recovery 2.0 process, we have focused considerable efforts on the recovery of complex mixed waste materials. One part of the stream of waste materials that we encounter is sourced from the solid fraction that is remaining after the first stage of the thermal reduction process. This waste stream is largely generated from microelectronics that contain numerous components that are too small to manually segregate. Once we have exhausted our efforts to mechanically divert and thermally remove the non-metal fractions, we are left with a residue pile that consists of a mix of base, precious, exotic and strategic critical metals residues. These metal residues are compatible for further refining and extraction by using a wet chemical process referred to as hydrometallurgy. This process uses a concentration and selective extraction approach for the recovery of each individual metal in sequence. Using an acid leach process that dissolves the mixed complex of metals into an ionic solution, and then selectively extracting each individual purified metal, we achieve a comprehensive recovery efficiency. The leaching process is carried out inside of a contained acid house and the acids are regenerated, as a normal part of the sustainable procedure. Due to the different properties of each type of metal, several different acid leach loops are required to achieve a full recovery process sequence. Each individual metal may selectively be recovered in a sequential order, according to the reactivity series. While dissolved in an ionic solution state, a selected metal may be precipitated or displaced into a purified metallic form. This is achieved by reacting the correct metal with the next reactivity series level. The hydrometallurgy mixed metal recovery approach is one method to address a group of materials generically known as heavy metals or trace elements, which include the spectrum of base metals, precious metals, strategic and critical materials and rare earth elements. The recovery of complex residues is a multi-stage process that requires a step-by-step diligence. The economics of such a complicated procedure, in an attempt to recover low-content trace elements, may be difficult to justify. We intend to discuss additional facets of the waste recovery sector at some point in the future. Until then, please feel free to contact us at your convenience. Recovery 2.0 is a project developed by Waste.net, in an effort to reinforce our belief that as rational human beings, we must accept the ultimate responsibility to leave future generations with a safe and sound environment, and a world that has not been depleted of its resources. Please feel free to visit us today at www.waste.net.